Welcome to the last video on probability. So far we have looked at introduction to probability, and in this video we're going to take a look at tree diagrams and grids and also rules of probability. So we're going to study the type of events which are called compound events. So we solve compound events using what are called tree diagrams and grids. So what are compound events? A compound event is made of two or more events that constitute one trial. So a trial is something we do in order to get a certain result. Okay, so if you have different events that at the end of the day you need to get the probabilities of those events as one probability, then that's a compound event. To make it simpler, let's say you want to know the probability of getting heads when you toss a coin 5 times. So you'll be tossing the coin 5 times, and at the end of the day you just want one probability, and that is the probability of getting a head in those 5 different events. So this is an example of a compound event where you want one thing from different events, or maybe different mini trials, but you take them as one big trial. So you want one probability for different events. That's what a compound event is. So we use tree diagrams and grids. So another example of which is of course the example which I gave, which is repeating an experiment multiple times, it is also a compound event. A different example from repeating an experiment can be doing two different experiments, but you want to get the probability of the two different experiments. For example, you can have tossing a coin and rolling a dice. So it might turn out that you want the probability of getting a head when a coin is tossed, and getting maybe a number 1 when dice is rolled. So these are different experiments, but you want the probability of getting a head or a 1. I mean a head and a 1. So you want the probability of getting a head when the coin is tossed and the 1 when the dice is rolled. So this, you are going to do different things, but you want to get the probability, one probability for the entire experiment. So that's another example of a compound. So we're going to start with a tree diagram. So a tree diagram, of course these are compound events, so a tree diagram has different trials. So we can have a first trial where something is going to happen, then we're going to have a second trial where another thing is going to happen, but at the end of the day we want to get one probability. With that being said, let's say we're going to do an experiment of tossing a coin. So in the first trial, actually before I can even go there, what we want to know is the probability of getting maybe we're going to toss our coin twice. So we want to see the probability of getting a head in the first trial and a head in the second trial, or maybe we'll see a probability of getting a head and a tail. Just like that, we'll have different outcomes using a tree diagram. So in the first trial, the tree diagram is going to show us all the possible outcomes. In the second trial, the tree diagram is going to show us all the possible outcomes. So we're going to start with trial 1. So if you toss a coin, then the probability of getting a head is 1/2, because we have one head on the coin and the two possible outcomes are head and tail, so it's 1/2. Again, if you if you do the same, the probability of getting a tail is also 1/2. So this is the first trial. These are possible outcomes in the first trial. So when you go in the second trial, here's how we're going to be viewing it. So we are going to follow this branch. So when you follow this branch, we assume that in the first trial we got a head. Okay, So if in the first trial got a head, again we toss the coin. What are we going to get? So we can either get in the second trial we can get a head again, and the probability of getting a head is still 1 over 2 because we have one head out of the two possible outcomes. So it's 1 over 2. What about the probability of getting a tail? It's still the same. So probability is 1 over 2. So if we're done with second trial, but this branch is incomplete, we have to complete this branch also. So when we go to this branch, here we assume that in the first trial, we got a tail. So what about the second trial? So in the second trial, what's the probability of getting a head? So the probability of getting a head in the second trial is still 1 over 2 because of one head out of the two possible outcomes. What about the probability of getting a tail? So the probability of getting a tail is still 1 over 2. So this is a tree diagram. So if you do two trials, the probability of getting a head in the first trial to get a head and in the second to get a head, you can write it as head. All right. Then the probability of getting a head in the first and a tail in the second, you can write it as head tail. Then the probability of getting a tail in the first and head in the second, you can call it tail head, and probability of getting tail is tail. So mathematically now, head, you can write it as probability of head multiplied by probability of head. So what I'm trying to say is the probability of getting head, you multiply the probability here and the probability here, because this is the probability of getting a head in the first and this is the probability of getting a head in the second. So probability of head is equal to 1 over 2 multiplied by 1 over 2, which gives us 1 over 4. What about the second one? So again, probability head tail, it's 1 over 2 for head, and for tail it's 1 over 2, which gives us 1 over 4. What about probability of getting a tail in the first trial and a head in the second? Still the same. Probability of tail, probability of head, it's 1 over 2 multiplied by 1 over 2, which gives us 1 over 4. What about the probability of getting tails, two tails? So probability of tail, we get the probability here and the probability here, we multiply them. So I have 1 over 2 times 1 over 2, which gives us 1 over 4. So this is how to make use of a tree diagram. It will give us all the information, all the possible outcomes, regardless of the number of trials. We could have had a third trial here, and again we're going to continue with this branch. We could have gone head tail, again head tail, again head tail, again head tail, just like that. So let's use a tree diagram to solve this different question where the probability, the results of the first trial affects the results of the second trial. So let's say these are balls. So we have 1, 2, 3, 4, 5 balls and 4 balls. So what is the probability? This is the first trial. We want to get the probability. What's the probability of getting a blue ball if a ball is picked at random? So picking a ball at random, the probability of getting a blue ball is, how many blue balls are here? 5. What's the total number of balls that are in here? 9. So probability of getting a blue ball is 5 over 9. Next, we go to a red ball. So how many red balls are there? 4. What's the total number of balls? 9. So it's 4 over 9. So when you complete a branch, just to ensure that your calculations are okay, when you add these two probabilities, they should give you 1. 5 over 9 plus 4 over 9, it will give you 9 over 9, which is going to be equal to 1. Next, we go to the second trial. So in the second trial, we should have this in mind. When you go to this branch, we should know that here we assume that one blue ball has been taken out. But when we go to this, we'll assume that one red ball has been taken out. Then we do the probabilities. So let's go to this one. We assume that one blue ball has been taken out. Now, what's the probability of getting a blue ball? So since the number of blue balls are now 4 out of the total now are 8, the number of blue balls have reduced by 1 on top and on the bottom. There were 5, now 1 is out, so there are 4. And the total number of balls were 9. Since 1 is out, there are 8. So we have 4 over 8. What about the number of red balls? So the number of red balls are still the same, there are 4, but the total number of balls, they have reduced by 1. So probability of getting a red ball, if in the first round we got a blue ball, it's 4 over 8. Again, if you see, when you add these two, they are going to give you 1. We go to the second branch here. So here, on the side of red, we assume that here, one red ball has been taken out. So we start again. What is the probability of getting a blue ball? So how many blue balls are here? There are 5. How many total balls are here? There are 8. So it's going to be 5 over 8. What is the probability of getting a red ball? So the probability of getting a red ball is how many red balls are here? There are 3 out of the total, which is 8. So this is the probability of getting a red ball. Now, for our analysis, we can combine different outcomes. So blue ball, it's BB. Blue, red, it's BR. Red, blue, it's red, RB. Then red, it's RR. With that, we can now find the probabilities of getting BB. Like in the first trial, you get B, and in the second trial, you get B. So we're going to say probability of getting BB is 5 over 9 times 4 over 8. 5 over 9 times 4 over 8, which gives us 20 over 72. What about the probability of getting a blue ball and a red ball? So the probability of getting a blue ball and a red ball is 5 over 9 times 4 over 8, which again gives us 20 over 72. What about the probability of getting red and blue? So it's 4 over 9 times 5 over 8, which gives us 20 again over 72. And finally, red. So probability of red is 4 over 9 times 3 over 8, which is going to give us 12 over 72. So these are different probabilities. If they ask you to find the probability of getting a blue ball at first and a blue ball at the second trial, the answer is this. Blue ball at first, red ball at second trial, the answer is this, just like that. Next, we look at grids. So a probability grid is just a table that shows all the possible outcomes of a trial that consists 2 events only. So this one is used if there are 2 events only. For example, tossing a coin twice. So the first event is when you toss it at first, and the second is when you toss it at second. So in such a case, this is how to come up with it. So you write possible outcome of the first event, head, tail, on your far left. Then on top, you're going to write again possible outcomes of the second event, head, tail. Then you start combining them. Head, then head, tail, then here tail, head, then here tail. Normally we work with tree diagrams, not grids. But anyway, it is very they can be very helpful to solve some problems. So with that being said, let's say these are your possible outcomes. How do you answer probability questions from? So the first can be the probability of getting head. So the probability of getting head, you ask yourself how many head are here? It's 1 out of the total 4. So it's 1 over 4. Probability of getting head or TT. So how many head or TT are here? We have got 1 and 2. So there are 2 out of 4. Probability of getting at least 1 head. At least 1 head means 1 head or more than 1 head. Here we have 1 head, here we have 1 head, here we have 2 heads. So all these are possible outcomes. So we have 3 out of 4. We end this topic with what are called rules of probability. So the first rule is for mutually exclusive events. Events A and B are mutually exclusive if they cannot happen at the same time. So 2 events are mutually exclusive if they cannot happen at the same time. For example, is 1 tossing a coin. So if you toss a coin, the chances that you might end up having a head and a tail at the same time is not possible. You can only have a tail or a head. So such events are said to be mutually exclusive. Another is rolling a dice. So a dice has got 6 corners. Each of the corner is made of one number. So the probability of when you roll a dice you get two numbers is not possible. So that's another example of mutually exclusive events. There is no chance of getting maybe 1 and 2 on the dice at the same time. It's not possible. So mutually exclusive events A and B have the following probability rule. So the rule for mutually exclusive events is probability of A or B is equal to probability of A plus probability of B. So the keyword that you should keep in mind to tell if events are mutually exclusive usually is the word or. When they say the probability of this happening or this happening, it means those events are mutually exclusive. This can happen or this can happen. They cannot happen at the same time. So the word or is usually interpreted as plus. In probability, the word or is usually interpreted as plus, which means this implies that it's probability of A plus probability of B. Another rule is independent events, the rule that applies for independent events. So what are independent events? Events A and B are independent if the occurrence of one does not change the occurrence of the other. So two events are independent if when one happens does not change the other one happening. Example is tossing a coin and rolling a dice. So if you get a coin on one hand and a dice on the other hand, then you roll the dice and you toss a coin. The events of getting a head on the coin will not affect the chances of getting maybe number 1 on the dice. They are independent. What one does, the results of one or whatever happens with one does not affect the other. So these are independent events. So independent events A and B have the following probability rule. So probability of A and B is probability of A times probability of B. So again, in probability, the word and usually implies multiplying and multiplying. So the probability of A happening and B happening is probability of A times probability of B. So these are examples of independent events. Or I mean, this is the rule that applies for independent events. So let's take a look at these examples. A coin is tossed. Find the probability of getting a head or a tail. Just from this word, head or a tail, you should tell that this is a mutually exclusive event. Means that we have to get the probability of head and the probability of tail, we add them. So probability of head of tail is just probability of H plus probability of tail, which is half and half. We're going to add them and we're going to get 1. The other one is for independent events. A dice is rolled and a coin is tossed. Find the probability of getting a tail on the coin and a 1 on the dice. So these independent events, well, because of the word and, you should be able to tell that they are independent, and meaning that we have to get the probability of a tail and the probability of a 1 on the dice. So probability of tail and 1, so we multiply them. So probability of tail it's half, but for the dice there are 6 numbers, so if you get 1, you're going to have 1 over 6. For those who don't know what a dice is, it's just a cube that has numbers, or it's maybe a box to put it, which has numbers on its faces. So there are 6 sides of a box. So on each side there are numbers 1, 2, 3 up to 6. Okay, so the probability of getting a 1, it's 1 over the total possible outcomes, which are 6. So it's 1 over 6. So the probability is half times 1 over 6 equals 1 over 12. I could have solved the question, but hope this is going to be enough. And for tree diagrams, let's say they have asked find the probability of getting, for example, in our previous example, find the probability of getting both balls or both blue balls or both red balls. So there is O. So you have to get the probability of both blue balls, then you add it to the probability of both red balls. Okay, so that's just an additional trick on how to deal with tree diagrams. So the word O means plus. So if they say find the probability of getting both red balls or both blue balls, you get the probability of both red balls, you add it to the probability of both blue balls. So that's how to tackle probability. This marks the end of this video. Hope you have learned a thing or two. Happy solving.